Hi, my name is Praveen Singh Newa. This is Project 3 for CS6320 class. I'm talking about a scope query language, which is a language, Microsoft version of big data query language. User on the internet has grown dramatically. That's why for the uh, job like data mining of the huge data, it is the conventional database system is not suitable. So most of the company like Google, like big company like Microsoft, they come with a big data solution called NoSQL has been really popular, and this page actually compare some of the key differences between relational database and non-relational database, which is known as NoSQL. You can see a relational database is data is stored in table, where in NoSQL data is stored in a flat text file. Relational database is vertically scalable. That means you have to need the add of hardware like a memory in a single server. Where in the case of non-relational database, you can add more servers. That is horizontally scalable. For relational database, you use a SQL structured query language, which is a standard across different systems. But in case of NoSQL, they use unstructured query language. It looks like SQL, but it could different from system to system. And relational database system is suitable for complex queries. It's relation between different tables. But non-relational database is good for huge databases. Relational database is hierarchical data storage is not possible. But in case of non-relational, you can establish a hierarchy between the data. You can treat the data as an object. And again, in case of relational database, the technology has been here for more than 30 years, so it is really mature technology. You can get a lot of good support online, anywhere, books, but non-relational database is not here for a long time. It's just emerging technology, and there is limited support. And relational database is it emphasizes on ACID properties: atomicity, consistency, isolation, durability, whereas non-relational databases follows CAP theorem. That explains CAP means consistency, availability, and partition tolerance, and only two things out of three can be achieved in distributed system. So if data integrity is the most important thing, you have to use relational database. But if you don't care about the data, but you just need to do data mining analysis of used databases, then non-relational NoSQL is good choice for you. For example of relational database is MySQL, Oracle, SQLite, Microsoft SQL. Whereas the example of NoSQL, it'd be MongoDB, Bigtable, Redis, and the Scope. Scope is the one I'm going to talk about today. What is Scope? Scope stands for Structured Computation Optimized for Parallel Execution. Is a non-relational NoSQL data query language developed by Microsoft, which is targeted mainly for analysis of massive data for making business decisions. So currently now it is just used inside of Microsoft. Like other big data solutions, SQL has borrowed syntax from conventional SQL. But the plus point is it is really integrated with .NET framework, which has made this tool very powerful. So you can see in the chart, it runs under underlying environment called Cosmos. So Cosmos Storage is a Microsoft internal distributed computing environment for parallel computation of job. The data is stored as chunk of series of small files, which should be only few megabytes in size, which are known as extend. This file gets stored as a compressed form for the higher network throughput. The file gets decompressed on the client side transparently. In addition, files are highly optimized for large sequential I/O intensive tasks. All files are stored in hierarchical namespace. And the main the emphasis given by Cosmos storage environment is like for availability, reliability, scalability, and performance. The Cosmos storage system platform is highly fault tolerant in both server and network level. Files are replicated within the servers and also between different servers with quorum group of 2f plus 1 in order to tolerate up to f failures. This is how the availability is gained in Cosmos storage system, which is the underlying system of where the scope query runs. The reliability to avoid the corruption of data, system components, and on-disk data are checksummed periodically. This is how data reliability is maintained. About scalability, more servers and network hardware can be added to scale on the underlying system without higher application system being aware of it. And for the performance, like other distributed system, attacks is break down into smaller pieces and distributed to multiple servers for the parallel execution. This is how performance is achieved. Job execution. So this is how the job, when you send some job to the uh, Cosmos environment using the scope query, the job is during compile and the optimization stage first directed acyclic graph representation of job is made. The edge represents the flow of data and the vertex represent the data processing. DAG representation of data is created by a component of executing engine known as job manager. Then job is distributed across multiple servers for parallel execution. While distributing the job manager also tries to spread them across physically closely located server, usually in the same rack if available for the best performance. Job manager also monitors the job until the completion and re-execute the failed jobs if necessary. Data representation. So scope supports mainly two types of data representation for input and output. They are structured and unstructured streamed. The diagram below shows the high level how the input and output works for both structured and unstructured streams. We will talk about more on the next page. So in the chart you can see this is left side is the input part. If the data is unstructured stream, it has to go through extractor and then only send for the processing. But if it's a structured stream, it can directly use for the SQL, the scope query for the analysis of data. And the same thing on the right side. If it is a unstructured stream, if you want the output as an unstructured stream, you have to it has to go to the outputter so that it knows how to uh, output the data. Like you want as a CSV or XML, but in case of structured stream, since it is already has a schema, you don't have to specify anything. More about structure stream. Structured stream is a data with schema information included. It also includes metadata, which scope uses for the optimization of the query during runtime and the compile time. It is equivalent to the data which is defined in table in our conventional relational database system. So if input is, like I mentioned earlier in the chart, if input data is structured stream, user can directly run queries without implementing extractor because the data already has a schema information. Similar in case of output also, you don't have to specify anything. So for example, uh, you can see below like it uses select all from the SS stream defines it is a structured stream. My input SS where there is a condition looking for, and this the first line is the from, this is the input part, and the second line is the output to the file. So you can see there is not any extractor or outputter is needed. But in case of unstructured stream, the things get really a little bit complicated, because unstructured database doesn't have any schema information. So if you want to input data, the data has to be extracted first, because you need to tell how you want to parse the data. So in simple cases, like if the column are separated by white space, or they are comma delimited, user can actually use a built-in extractor named default text extractor. Like in this example, you can see uh, it is using extract time domain. These are the columns using default extractor here, and the data processing happening on the middle line, and then for the output, you can see it is again using default text outputter. Or if you want to use your custom uh, extractor or outputter, in for example, if you want to export as XML, or if you want to read XML file, you can define your own custom extractor or outputter by extending the corresponding extractor and outputter class. You can see here in this example. Similarly, here in the data output side, it is extending the outputter class, and you can use here like this using XML outputter. Here. Next is scope query is very SQL friendly language. Since it is SQL friendly, anyone who knows SQL syntaxes can read and uh, work with scope query without any further knowledge of it. So it's very time saving thing. And here is the list of the most common SQL operators currently supported by scope query. There are selection, select statement, projection, join like inner join, outer join, and cross join is supported now. Set operation like union, union all, intersect, and difference. And the aggregated function which are supported right now is count, countif, min, max, average, standard deviation, sum, vary, and first, last, and distinct. And the one different thing from other relational SQL statement is this output of one statement can be assigned to a variable, like here. Select, this is select, and it is assigned to result one. And result one is used in the second statement, like here. Select date count all as from result one group by date. This makes the complex queries breakdownable into the simple multiple statements. And at always the last line of the scope query has use output, so that to write the result into the file. Finally, the most powerful thing in the scope query language in compare with other big data solution is it is tightly integrated with C Sharp. All of that means all of the built-in C Sharp expression and method can be directly used in the scope query in the select statement. Like in this example, you can see select name, address, and birth date. Since birth date is a C Sharp date time data type, you can directly use one of the properties called day of year right here. This makes it very easy and powerful. You can do a lot of stuff. In addition to that, you can also define your own function as a C sharp statement, and you can use like here in the example. You can see is here in the select statement where clause is actually using add number function to add age and height and compare with the number. This is the bibliography page. Thank you very much for your time.